All right, let's get right into it. We live in a world that pretty much demands two things from us: stay connected, but also be on the move. And right there, that's where things get complicated. Today, we're going to unpack that fundamental conflict, the constant trade-off between mobility and bandwidth.
Come on, you've been there, right? You're on a super important video call, it's all going smoothly, picture's perfect, and then you stand up to walk to the kitchen. Bam! The screen freezes, the audio glitches out, and everyone sounds like a robot. So what's the deal? Well, that little moment of frustration, it's actually part of a much, much bigger story.
See, this isn't just your Wi-Fi router being difficult. This is a core challenge baked into the very fabric of wireless communication. The simple act of moving throws a whole wrench into the works, creating problems that engineers have been wrestling with for decades. Seriously, keeping a fast, stable connection while you're in motion, it is one of the toughest nuts to crack in technology.
Now, you might be sitting there thinking, but wait, my internet gets faster literally every year. And you know what? You're absolutely right. There's even a kind of law that describes this. But, as we're about to see, just because the whole network is getting faster, that doesn't mean your connection magically gets better when you're on the go.
It's called Edholm's Law. It's kind of like the famous Moore's Law for computer chips, but for networks. It basically points out that the total capacity of our communication networks doubles roughly every 18 months. You can think of it like a giant fire hose of data that's just getting bigger and bigger year after year.
Which, of course, brings us to the real question, doesn't it? If we're living in this golden age of exploding bandwidth, why does walking from your living room to your bedroom still feel like you're crossing a digital desert sometimes? Why do our connections still feel so incredibly fragile?
And here is the absolute key. Edholm's Law is talking about the massive potential of the whole system, the size of that data fire hose. But your phone or your laptop, it's just trying to take a little sip from that fire hose through a very, very shaky straw. Things like signal interference, walls, and having to switch between cell towers, that's what messes everything up.
So how do we fix this? Well, let's start by looking at some of the most extreme situations imaginable. Places where a stable connection isn't just tricky, it's basically impossible. This is where the solutions get really, really clever.
So first up, we have something called a wireless ad hoc network, or a WANET. The idea here is pretty radical. Just get rid of the router entirely. In a WANET, every single device, your phone, a laptop, whatever, becomes a part of the network. Each one helps pass messages along for everybody else. It's a totally decentralized, self-healing system.
Now, this constant change is both the magic and the madness of a WANET. Because every device can move, the network shape is always shifting, breaking apart, and reconnecting. That makes things challenging, sure, but it also makes the network incredibly resilient. It's perfect for a situation like a disaster zone, where all the normal infrastructure is gone and first responders need to create a new communication network right there on the fly.
Okay, but what if the disconnections last for, say, hours or even days? For that, you need a completely different way of thinking. And that's where delay-tolerant networking, or DTN, comes in. The name really says it all. It's a network that is built from the ground up to handle massive, massive delays.
The whole philosophy boils down to one simple, elegant idea. Store now, forward later. Instead of trying to send a message immediately and failing, a device just holds onto the data. It stores it, and it waits, patiently, until it comes into contact with another device it can connect to. Only then does it forward the message along.
I mean, this is a complete mindset shift, right? The regular internet we use every day is obsessed with real-time, constant connection. DTN just throws that whole idea out the window. It doesn't care about right now, it only cares about eventually. The number one priority is making sure the message gets there, period. It doesn't matter how long it takes.
So where on Earth, or off it, do you use this stuff? Well, the examples are just wild. We're talking about building an interplanetary internet, sending data from a Mars rover back to us when the signal delay is measured in minutes or even hours. But it's also used right here at home, like on a bus, driving through a rural area with no signal, collecting data and only uploading it all once it gets back to a city.
Okay, so interplanetary communication is awesome, but what about that stuttering video call we talked about at the beginning? Let's bring things back down to earth and look at the tech that's making our everyday, on-the-go lives a little bit smoother. Now here's a piece of tech that might actually be working in your pocket right now, and you don't even know it. It's called LTE WLAN aggregation, or LWA, and the idea is just so practical. Why should you have to choose between your cellular data and your Wi-Fi? Why not just use both at the same time?
Honestly, the best way to think about it is like a turbo mode for your phone's internet. LLWA basically fuses your two connections, your LTE and your Wi-Fi, into one single, faster, more reliable pipeline for data. It's like hitting a turbo button to get a speed boost right when you need it most.
So how does this magic actually work? Well, it's pretty clever. Your phone holds on to its main cellular connection, and the cell network kind of acts as the brains of the whole operation. When it spots a good Wi-Fi network nearby, it connects to that too. Then the network is smart enough to split up your data, sending some bits over LTE and the rest over Wi-Fi. And it all gets reassembled on your device, giving you a way better combined speed.
And what's the result of all this? Well, it brings us right back to where we started. You get a much more stable connection that can actually handle things like streaming high-definition video even when you're moving around. It's a direct answer to our everyday mobility headache.
Okay, so we've gone from disaster zones to deep space and all the way back to a turbo mode for your phone. So what does this all mean when you put it together?
Well, it really just boils down to using the right tool for the right job. If you have no infrastructure, you use a WANET. If you know you're going to have massive delays, use DTN. And if you've got two decent connections and you want to make them one great one, that's what LWA is for.
So, at the end of the day, here's the big takeaway. There is no single magic bullet for solving this problem of mobility versus bandwidth. It's not about finding one perfect solution. It's about looking at the situation you're in and making the right, smart trade-off to get the data where it needs to be.
And that kind of leaves us with one final question to chew on. Our expectation for perfect, fast internet everywhere, in our cars, on trains, you name it, that's only going up. That basic conflict between moving and staying connected isn't going away. So you have to wonder, what's next? What clever new trade-offs are we going to have to invent to keep up?